This time on Captain Castle's laboratory, we're working on the spinning snowflake. It's a tall piece, so if I tip it over, it's taller than my screen. So, this one's interesting. I've never repaired one. I have taken one and have extended this about 4 feet for a display. So this is a first to work on. Woo, bam. Kind of hits a little hard there. It's kind of weird. It does it backwards sometimes too. But the reason it's here is the name of it's called the spinning snowflake. If you notice that it's not spinning. Sound and lights work. So, and this is a resetting piece. You turn the power off. Still, there you go. So you have to let it reset. And either it's counterweighted, probably up here and down there, or it's got magnets. There's something in here that's keeping it from standing straight up. If you try and push it straight up, it will readjust itself. So I'm thinking there might be a magnet or a counterbalance somewhere between here and here. Anyhow, this piece down here is supposed to turn. It doesn't turn. And on the bottom, this is a, that's why they call it the spinning snowflake, is we got a snowflake. Here's the biggest issue. There's screws underneath this sticker. This is a sticker. I'm sure a lot of you know how hard it is to remove a sticker and not have it get damaged. I believe there's screws. The reason I say that is this is a motor that turns this, and I can't imagine it having a geared shaft through here, and it might. I mean, I could be completely wrong, but it doesn't make sense to have a drive shaft go down the center and have something either up here or through one of these arms. But I noticed this isn't attached, so let's take a look in here real quick. And here's a big chunk of metal. So that would be my counterweight. The bottom does open. There's 1, 2, 3, 4, 5, 6 screws. So why don't we just take a quick peek inside the bottom and see if maybe we can get a better idea and verify that the motor is actually right there. Also, we'll be able to figure out if it's a magnet or a belt drive. So just like all of them, it's got the 6 feet. A lot of them, not all of them. So we just got to pop out the 6 feet to access the 6 screws. One more. All right, 6 feet. Two. 3. 4. Number 5. And last but not least, number 6, which is really tight. I think they might have got glue on this one. There we go. All right. Well, I was wrong, but on how this thing functions, but it's pretty close. I'm surprised. As far as the engineering in this has a 8 ohm 2 watt speaker right there. So it's one of the more higher quality ones, which is generally found in the Christmas line. You got your motor right here, which luckily the grease is underneath this pulley. So storing this standing straight up, the motor should never get greasy. If you store it upside down, it will. Belt looks and feels good. I see no powder, dust, or wear. So how this works is it goes, of course, through its little gearbox. The gearbox transfers right here with an impossible gear into this gear here. This gear then moves this eccentrically, meaning the gear moves and this plate slides back and forth. Now, what I do notice is I got 1, 2, 3 screws, but I have a missing one right there. So I am not sure if some dude at the factory screwed up and didn't put one in there, because there's no threads cut in this hole either. So maybe it's not supposed to come with one, but that makes no sense, because without that extra screw, this plate lifts really far on this corner. So I'll look. I should have a flat topped screw to put in there. The plate should have slack, or else it can't do that. Now, this pin fits into a bar on the side. This bar is an eccentric. So it goes up this arm, moves eccentrically, which causes this to and then back. And that sounded so technical. But what it does is kind of like the bar on an oscillating fan. If you had one of the old stand fans that the head moved back and forth, if you ever take the cover off, it has an eccentric. And that's what this is. This is part of it, and the other part of it's inside this column. And when the bar moves back and forth, it's pivoting up here, moving the arm back and forth, which is the snowflake. The bottom is just plastic. There's nothing to see, except I can feel the stickiness of the sticker, which is also right here. There's another sticker. So instead of this one being painted, this one's got a lot of decals. These are all decals on the table. These are decals on the side. And this is a sticker. And of course, the bottom of the snowflake's a sticker. These are stickers. I mean, it's a whole bunch of stickers. So if you have to disassemble the arms, once you take the bottom off, you can see the tab here and here. There's 4. There's 2 on the top and 2 on the bottom. If you squeeze these tabs together and then push right here in the center, you should be able to pop the arms out very carefully, because these wires here and these wires here control the lights, the lights, the lights, and send power up to the motor. So I'm going to assume that this one here is the motor. I could be wrong. Let's see. And the reason I say that is it's the only one that's different than the rest. Magnifier, LED, LED, power, power, speaker. Where's this guy go? Right there. M1. Where's M2? Speaker. Oh, this is your distribution board wire, which probably distributes it down the shaft to the motor. So this will be connected to the motor. Probably up in here is a distribution board stuck against the side. I doubt they ran it down the center. They might have. I don't know. We're going to try and find out together. So this is an SRF 300CA motor. You've got standard gears in the gearbox, that I can see. It's a standard belt, standard pulleys. The only gear that's special are the gear here and here, which make this eccentric work. So a standard gear kit should take care of your gears if you happen to break one. Here's a flat head or flat top screw. Will it fit, or is it too fat? Too fat. All right. here's a small guy. It's going to be a little harder to put in because I have to cut the threads. There, not as much deflection. Now we're going to put this back on. So put it on, you have to put it in a slight angle so you can get that pin back into its slot, which is right there. And it slid out. There we go. And I'm going to hold the base on, or put pressure on the base so I can get some of these screws back in. So if you ever open this piece and you open the bottom for some reason, maybe to replace the belt or the motor that causes it to swing, comment below if yours is missing a screw or if it had all four. So I'm just going to put in 3 for the moment. That way it's snug and holding it. And now let's see about trying to get this snowflake apart. Do a little close examination. See if I see anything. You see that it does separate. I'm assuming it's because there's screws. I'm just going to put a little pressure. Yes, there's screws in the corners. So there is no magnets. When this thing is pivoting and sliding, it's the counterweights acting on the slack in the eccentric bar that's inside. Again, this one. So staring at the stairs, it's the bar on the left. And like I said, these, actually this is paint. Feels like a sticker. These are stickers. That's a big sticker. You can see, I don't know. You see how I flex it? Hopefully. That's that hole in the center that I said was sticky, because that's the bottom of the sticker's adhesive. I'm trying to find the best way to position this to where I can access the bottom. Just want something to put pressure on here. Maybe this hot glue whip will do it for me. Not enough. I tried. So I'm going to try heating up the sticker and see if I can peel it off. Normally when I take stickers off, I usually get them wet, and those are stickers I'm just trying to remove from something to throw away. I'm not trying to salvage the sticker. So this is going to be interesting. If you have like a Cricut machine, you could remake your own. It'd be a layered one. You just cut out a piece of blue vinyl in the shape of the octagon. And then, actually it's not an octagon, it's only got 6 sides. Yeah. I don't know what a 6-sided one's called. And then you would cut out the pattern of the snowflake in white and stick it on. So if you have crafting abilities, you can do it. You can also modify it and make it your own. So I'm just going to double check to see if any part of the sticker is starting to peel. And if I can, I'll only try and peel where I think the screws are. Because I can lift, right, it's off camera because of the size of this thing. I can move this piece, but I can't move this point or this point. So I'm assuming there's a screw here, here, and then the bottom center. 3 of the 6 points. So I'm going to just try and heat up where I think a screw is, so I'm not peeling the whole sticker. And then be careful with your heat, because too much heat will cause discoloration. You'll make sure you move your heat around and check. Looks like it's starting to lift. And yes, I'm right. There is a screw. So let me do the other 2 spots that I think the screws are. This is actually working really good. The sticker is separating and curling. So I can get to the screws easier. And to stick it back on, you can use spray adhesive or rubber contacts, and that would probably work really good if your sticker doesn't have any more stickiness. I would not use super glue or hot glue because super glue is going to make it more permanent and hot glue is going to make it lumpy. And there's the motor. So there's the bottom. And you can see the 3 screw holes, and you can see just by heating the points, I only peeled that much of the sticker off in each of those 3 points. And then, of course, this is sticky because, again, it's a sticker. So I can use the stickiness, hopefully, to hold die screws. And move this out of my way. So on the bottom of this is the motor. It also looks like a 300 CA motor. I'm going to try and tip this so you can see it. It's sideways. There's the plug, and there's 3 screws. And it's staying now because I removed some of the counterweight. So if I'm right, these 3 screws should remove the plate and not the whole base. If I'm wrong, the whole base will come off. Either way, it needs to come off so I can get to the motor. And again, sorry it's not quite centered because of this thing's size. This is not a small one. But I will move it in a second once I get those 3 screws out. There you go. Now the 3 screws are out. Is there any other screws hiding under the hot glue? Nope, it's just the hot glue holding it in. And now we're losing gears. That is what it is. Like, no joke. Gears. More gears. So if you have this, you might want to break the hot glue free first before doing this. And you might do this while it's laying on its back and pointing straight up so you don't lose the gears. Alright, so yes, that is a distribution board wire that goes up, and then there's 2 wires come back down, which are green and black, same as the light wire colors. This motor is slimy, which means it is full of grease. Now I just got to figure out how we're going to get this thing out. Oh, okay. Because the screws are facing this way. You know what? Let me stand up, tip this on its back, and try and do it standing versus sitting. Make it maybe a little bit more visible for you all so you can see what I'm doing and I'm not describing it and you're just like, I don't know what you're doing, I can't see. So this is probably how you should work on it at your house. So we have the drive gear and 2 planetary gears. The drive gear is the impossible gear. You have a worm gear, then your transfer gear to the drive gear, and 2 planetary gears. The drive gear goes here, and the planetary gear goes there, and there. That, and that are the screws. The screws that hold this in are right here and right here pointing this way. There are clips that hold this base on, but I don't know if that'll actually come off like I want. Maybe. It's getting caught on the chairs. Come on. One of you guys has got to be different than the other. one of these chairs ain't like the others. Yeah, that one. Well, one. What about the other one? You need two. So the girl in pink and the guy in yellow, their backs aren't as deep. And then we can pop this off. And they're so much more accessible. Oh, and this thing barely fits. Try not to drop the screws down the arm. I'm going to try not to, but, you know, Murphy says it's going to happen. Oh yeah, I don't know if you can see the sheen of grease. It doesn't need this much wire. You can see it's just bundled, so I'm gonna not make as much. And then into the box you go. Grease is great for the gears, not for the motors. 99% of the time you just lose a motor because of the grease. I'm assuming that's what's wrong with this one. I don't know. I have to actually plug one in, but in doing so, this is going to try and swing, and if it's sitting like this, you're going to break something in the base, or you might break the arm up here. So we are just going to make a full assumption, based on the history of Lemax, bad motor. Also, it's full of grease, so bad motor. So we're going to pop in a new motor. I'm not a Christmas collector. If you've watched the channel, I've mentioned it many a times. But I do like some of the Christmas things as far as how they work and their colors and their lighting. So like this one, I like the lighting because the lighting is, they're sequential chasers and it looks nice. And the motion's kind of cool. It reminds me of those magnetic ones you see for solar, where they swing in the sunlight because the sunlight provides solar power to the electromagnet inside of them. So it is kind of cool. I'm not a Christmas collector. One, I would need to have a mansion to fit them all, and two, there's too many. But I do appreciate the lighting and the coloring. This one's got decent coloring. I like the shade of blue they use. Red, I think, should be a brighter, more brilliant red, but I'm sure they're going for a more muted red so it doesn't stand out as much. That way you can see more of the blues, which indicates cold, you know, snowflake, cold. But I don't know, I think a bright red would have helped it out some. The tabletop thingies that go around the base, which I have no idea what they're for, because if you had a table, you get smacked by the swinging thing if you were sitting there. Those are kind of cool with their little snowflake designs on the top, and the snowflakes are different for the different colors. So I may not collect them, but I can appreciate the styling involved in them. And some of these I can appreciate the intricacy of how they assemble them. Like this one using a eccentric. I figured maybe this one would have been an electromagnet like the miniatures that you buy at the dollar store or the $1.50 store, wherever it is now with the new inflation, where the sun powers the electromagnet and that gives you your motion. Magnets have been used a lot for different things, for stuff like that. So that's what I figured this did, the way it tried moving back and forth with the counterweight. But it's just trying to find an equilibrium because the weight on the top is heavier than the weight on the bottom. the motor. Just pop on the worm gear. When you push it on, make sure that it does not touch the actual housing. You want a really tight gap, but you want to be able to, if there's a little splay, you want to make sure that when it's pushed in all the way, which is where it should normally sit, that the motor is not touching the motor and the gear are not touching each other. Same with the pulleys, but the pulleys you don't leave that a problem because you're trying to align the pulley to the other pulleys so your belt track straight. In this case, you're trying to just put a motor in. So set the motor back inside, and now line up the screw holes. And I'm just gonna get this started. The reason I say that is this motor moves up and down inside these screw holes for alignment. So I'm not going to make it super tight. I want to be able to still slide this up and down so I can align it to the drive gear. Once I get the drive gear lined up, I'll tighten the one to pull the gear back out and tighten the other. Actually, never mind. It doesn't. As soon as you put in the second one, it self-aligns. So disregard what I just said. Interesting. They give you the ability to adjust it, but then once you put it together, your ability to adjust it has been removed. There we go. And we have that. That. And that. I'm going to wipe out some of this excessive grease in here. You still need some, but you don't need it around the edges where the screws go. You just need it around the teeth. So I'm just going to remove a little bit of that. And pink and yellow person. If for some reason you do this and you pop these characters off, just glue them back on. It's like one of those brain puzzles. You gotta figure out which way it goes on. There we go. And apparently the pink one's now caught. The one that was earlier. There we go. Just changed my angle of viewing so I can see it better, and this gear has to go in last. So we'll lift it, pop the gear out. So just put in the satellite gears. There we go, because this gear sits on top. Make sure it's good. It's good. Alright, apparently this gear sits underneath. Should have taken it apart upside or this way so I could have seen exactly how this gear went in. So now it's just trial and error. Where did my fine point needle nose pliers? Nope, it doesn't go in that way. definitely goes in this way. There we go. Apparently I just didn't have it seated all the way. It wasn't engaging the drive gear. And there. Pretty self-explanatory how this goes in. As far as, of course I did it wrong right off the get-go, but as far as the alignments, because if you put it in the wrong way, you can't line up the screws. And with that shorter wire, you technically don't have to glue it, but you can. Now, let's test it before we finish the assembly. I need you to get back down, and we need to put it in. And nothing. Maybe we have a power transfer problem. I was getting it back to its reset point to make sure it wasn't a reset issue. Alright. Oh, maybe it's because it's not in all the way. Nope. Only problem with a ride like this is testing the power. So we're getting no power here. Get it back down to its reset so it turns off. Go. Now I need to check the power on the board, see if we're getting power to the distribution board. If we're not getting power to the distribution board, then we have to disassemble this whole thing. Or, sorry, if we are getting power to the distribution board, and that means a wire possibly broke somewhere in this long arm and or down the center. So much for it being quick and easy. But what's nice is I don't have to worry about it trying to activate with the bottom off because there's nothing to bind up the mechanism, since the whole mechanism is right here. The reason it doesn't want to keep starting is the gear underneath has come apart. Probably, that's probably why that screw's missing. It probably just all came loose. Probably a good thing I opened this thing back up. Because like I said, the one I worked on, that all I did was extend the power, this thing, for a display, it didn't have this problem. Ah, it's broken. That right there is supposed to be stuck right here. It's sheared off, which is why the eccentric has such a delay. Neat. Let me see if I can pull the broken piece out. Be kind of tricky. This piece is screwed into the top, so I'm trying to get this to start so I can unscrew this. I need something to grab onto. It's not going to. All I'm doing is unscrewing that again. Let's try wedging it. Here's the broken piece. Alright. And this is an optical sensor, which this, that tab, goes through, and that tells it where it is in its cycle. That's why I was having such a problem swinging and had to be push started, is because this is just bouncing around in here because it broke. It is repairable. Probably not the way you think. If you look, there's a little divot right there in the middle. You drill that out and you stick a screw through it that grabs that hole right there. Clean all the grease out, put some super glue there, and then put a screw in there. A flathead screw like that, or a tapered screw like this, that screws it in. It'll hold it in place. The super glue is just to help prevent it from shifting and give it a better bond. So it's 2 points of adhesion versus 1. But that is why this thing doesn't want to keep going, and it stops and stalls and slams hard, is because it doesn't know its position with the optical sensor. Now we need to find out why we're not getting any juice to this motor. I doubt it's caused by the optical sensor not being reset, so let's just try it one more time. Nothing. Nothing, honey. Oh, no optical sensor. Pretty cool how that works, huh? So, motor's on, power's off, through, counts as 2 swipes, turns it off. So that means full out and back to center. And that, my friends, is how optical sensors work. It's looking for a break in the light. There's a ultraviolet light or infrared light that bounces from one side to the other, and it's looking for this to interrupt it. There's a couple of pieces that Department 56 used, that not Department, Mr. Christmas, sorry, that uses an optical sensor as well. But our biggest concern is, why is this not getting any juice? Don't care about the optical sensor that's working as much as I care about that. And this is repairable, so again, not an issue. I think it was the gourd, the ghoulish gourd, that had the same thing, where the standoff had snapped, and I showed you how to drill it out and put a screw in it. Alright, let's turn this thing back on. And it should be that pin there. 1.5 volts going back and forth. 2.5 volts, so those are probably for the lights. So let's check this one here. Nope, that says LED. Can't imagine the motor. Oh, the motor might be over here. We have a gray. Surprised it's not labeled. I figured it'd be labeled with an M2. P5. Unless it's P5. A second. Apparently my work is calling. I'll be right back.
0, 3.
Alright, we are back. Sorry for that interruption. The interruption took me out the rest of the evening. But we're back, and while I was on the phone, I was testing to try and figure out what's going on. This plug here, which goes right there, so it's next to the what is this, the power? Yeah, the wire from the power is the motor that's right there. Well, the reason it doesn't work is I took the cover back off. I unclipped where the motor plugs in, and I noticed there's no tension on it. There's no tension on it because the wire is sheared. So technically I could pull this side out too. It's like, great. Not what I wanted, because now I have to figure out how to take this thing apart without breaking it, because there's no visible screws. So that's going to be a treat. And you can see the curve in the wire, and it's a clean shear. Well, if you follow this down, that's right here. Remember how this thing was bouncing because of that gear being broken? And that's what happens when it goes bouncy. So we have broken wires, and I need to figure out how to open this up. Wires go up this arm. Give me a second. Adjusting the amount of noise that's about to come in. So, looking at it, like I was mentioning, there's clips down here. I see an indentation up here, and I'm assuming this outer plate pops off. What I don't know, are there screws underneath these snowflakes? So, yeah. Right. Let's move some of this stuff out of the way. We can shift this over. Not quite big enough of a screwdriver. Let's try a spudger and see if I can pop the indentation, which is the a clip. Still no good. I think this one's going to be too big. Nope, that worked. So either there's a screw behind here or there's another clip. But you can see, well, you can't see. So there's an indentation. There we go. But it's flexing to right here. So I'm wondering if there's a screw behind these snowflakes, and that's why they're here. They're strategically placed. Didn't realize this thing was taking up so much room where you couldn't see what I was doing. So now the question is there something under these snowflakes, or is it just clipped? So I'm going to take this wedger. I'm thinking the snowflakes have a hidden secret. And yeah, they're pretty stout. I was hoping I could see maybe over the sheared... Hey, there's the sheared wire. Where'd it go? Right there. There's the sheared wire. Right here. Yeah. I'm wondering if I can feed this back down and fish it back out and see if I can fix it while it's in here without having to dismantle this entire arm. What I can do to make it a little easier is I can try and pull some of this slack up if it will permit. And I don't think it will, because I think there's a zip tie in here. Or a strain relief. Yeah, I think there's a strain relief. I'm thinking I should extend this a little. I'm wondering if the shears, because when this goes to full extension, this is too tight. Meaning, I should have had an extra 1/4 inch or 1/2 inch of wire before doing the full run. Because that is a clean shear, and none of the other wires are sheared. The other wires are the lights, which also go down to the center of the arm. There is 3 sets of wires that go inside this arm, and I don't know why. We got 1, 2, 3, 4, 5, 6 sets of wires that go in here. 3 go into the arm, so with this one it would be 4. And then we have 2 that go on this side. These 3 wired ones that are down here that I was showing you earlier, the gray, the black, and the green, there's one that goes down each arm, and that is for these arm lights, the chasers. This red connected one right here, might be able to see it better right there, is this light. So that's 3. Here's number 4. So I have no idea what the other wires are for. But, oh, I bet you these light up, but I don't remember. So that might be it. But they shouldn't go into the center unless it's a jump or a bridge. So how are we going to fix this where it works good? First, we got to figure out how to fish that wire down. Seems really easy, but there's a 90-degree bend right there. So it's got to go down and over. And I really don't want to pop these snowflakes off unless I have to get to the screws. Like I said, I bet you there's screws here. So we need to figure out a way to run, bend, or in and up to where we can feed the wire. A fish tape is normally what you would use, but the fish tapes, they're usually made for pulling large wire. And this isn't large wire, as you can tell. So we're going to try and devise our own. I think I'm going to use some solid core phone wire, the stuff that you might have seen me use in other videos. This stuff. Let's see what we can do. If you can do it without disassembling, you have less likelihood of breaking something else on the unit or causing additional damage. So of course I'm going to do my best to try other options before I just go into, let's heat it up and pop off these snowflakes, which most likely they're going to break. Or let's bend it and get it hot so this is more flexible and then has a wrinkle or a ripple in the plastic from the heat gun. So I want to try this first. And there's 2 wires here. This is wrapped wire. I'm trying to pull one of the strands out. There we go. So it's still rigid as a solid core, but it's flexible, more flexible. And yes, there's lights inside these cones or snowflakes. So I'm really hoping it doesn't get caught in anything, which it's doing immediately, because there are multiple wires that run down this thing. So I'm wondering if there's 2 sets of wires and that it goes 1 set, 2 set, and that's how it does the chasing on the center arm. Whereas this uses 1 set of 3, this is using 2 sets of 2. I don't want to do it again, but let's get this thing off. Close the. There we go. And off. And gear. So because I have these long, thin needle nose, and you might be able to do it with standard needle nose or tweezers, I'm going to try and go down and then grab. And I might have to use tweezers as well. Alright, going down is not working very well. It's hitting something almost immediately within the first couple of inches. So I'm going to straighten the wire, see if I can get past it. There we go. I don't think I'm far enough down yet. Let's see. Oh, I am. Okay. Alright. I'm going to try tweezers first, see if I can get in here. I cannot. Can't get in there either. Oh, look at it, bent itself already. But it bent in the wrong way. It bent that way. So I probably hit part of the spindle. What I need to do is guesstimate how far down I need to go. So I figure right about there for depth. There we go, right there. Let's try it again. And I'm going to heat up this snowflake. At the angle I'm going in, I'm grabbing the wires that are already in there and not this one. Because when I start to pull, I can see the wires start moving here, and this one's not moving here. So I got the heat gun turned on. And I'm going to apply some heat and see if I can get this snowflake to maybe move. I didn't let it fall. I controlled its descent. Just so you know. I got all the snowflake to pop off except for the top here where they apparently glued part of the actual flake. There we go. So there's the snowflake. And yes, there are 2 screws behind it. And let me show you those. First, let me put up these tools so they're out of my way. And I know where they're at. 1, 2. So I'm going to just unscrew these and see if I can flex a little bit more of this out. If I can't, then I'll have to take off these 2 snowflakes and, well, just remove the entire side. Well, that's going to pose a problem. There are glue in the tops of the screw heads, so I can't get a screwdriver in there. You can use a pick or something to try and gouge it out. I mentioned this in previous times, in previous videos, that this screwdriver here is cracked, so it's kind of a point. So I use this a lot for prying and picking out stuff because it's kind of shaped like a hook. So I'm trying to clean out enough of the sides of the X or cross pattern to get Phillips into it. Still nothing, and nothing. Let me try a pointier Phillips. Nope. No. Alright. See if I can soften some more of the glue. The problem with doing screw heads is they transfer the heat into the threads, which in turn transferred into the plastic bosses. Alright, that's one. And here comes number 2. There we go. So now I got more flex. And you can see the wires. I'm hoping I can get in there now because I really do not want to have to do this all the way, because you saw how long it took just to get these 2 screws to come out because of the hard glue. Again, these are not made to be repaired. Lemax will tell you that, and they will tell you to just buy a replacement. And if they don't make it anymore, they basically tell you you're SOL. So. Hoping I got enough flex. I can try and reach in here and find it. Or magnetic flashlights. They pick up everything. Oh, come on, not again. Don't make batteries like they used to. Let's see, is there enough light? No, there's a couple of sheared wires. Actually, all of them are sheared. Huh. Okay. Well, you saw how to take the snowflakes off. We're going to take this whole thing apparently apart, as much as I did not want to. So, there's only one wire that's not sheared going through the center. I'm assuming they were sheared, and I didn't cause it by the needle nose pliers, because I didn't, if anything was somewhat snug and this didn't move, I didn't pull far. But I removed the hot glue, and by removing the hot glue from the heat, we got that one and that one. So now we got 3. And the big issue is which one's which, because they're not all the same power. So now we got to do a lot of tracing. And the 4th one is still intact, which is right here. You can probably see in the, right there. So great. A lot of tracing. Well, this one says LED. Which LED? This one says LED. Same thing, which LED? All the lights are on. That is so strange. So the wires are sheared, but every single light is on. Anything will block it. I just use that. As long as you block the light, it'll turn off. Weird. Unless it's the lights for this sign. And I see there's a wire now that I have it in this position, and this didn't light up. So I bet you it's for this. Alright, so what I'm going to do to save on time, because I'm sure this is a very long video now, I'm going to pause the video, and I'm going to heat up the sides, and I want to get these 2 snowflakes off, dig out the hard glue, and get this whole side to pop. So it's got this little pin here that you push with this screwdriver or a spudger. You can see the tooth right there. And then You got 2 screws, 2 screws, 2 screws, and then there's another clip right here on the bottom. You can be clicking it because it's just a standard plastic clip. And then right here where this Christmas tree is, they got some overgluing, so I'm gonna have to pry this off. This Christmas tree is not attached to the arm, but they got glue right there. So gonna have to fix that too, which may have been from the Christmas tree or when I put the snowflake on, because the snowflake, of course, is hard glued. And then we'll pull this entire, I guess, right side off. Yeah, right side, because this would be the front. And trace all these wires back. See where they go, see their powers, and get them all hooked up and rerun them. And if they are too tight for the motion that this thing makes, we'll put a little slack in them. There is some slack down here once these are pushed in, but once this is pushed in, you don't have the ability to slide this up the arm. So maybe we'll have to put this on first and then pull the slack and have the slack here at the joint. Or when these are fixed, we make the splices longer. So instead of just splicing them wire to wire, which technically makes it shorter, because when we cut and splice, we've now shortened the wire by 1/8 inch, 1/4 inch, 1/2 inch, depending on how big your splice is. Maybe we splice in some new wire, whether it be this solid core stuff, which I probably won't use because solid core, after being moved a whole bunch, tends to break. Or we'll just use some red and black striped LED wire. Or I have some other LED wire I put over here somewhere, like this stuff. It's really flexible, and I have it in a couple of colors. They're all short sections, but it's flexible wire. This is white. So the color doesn't matter as long as you match them up. But we don't want to use anything hard because then it retains its shape, and then the more you move it back and forth, it causes what we call work hardening. It'll eventually just snap. So I'm going to look for some flexible or stranded wire so we can actually fix this the proper way and hopefully get this thing back up and running the way it's supposed to be. Oh, just FYI, before I forget, the original motor that was in here, I did plug it into my power supply just for giggles, and it's bad. It works. It's a little loud, and it draws too much power, which means it's dying because of the grease that got in it. So eventually it would have had to been replaced. Right this minute, no. Down the road, yes. So take that for whatever it's worth. But it was a motor that was on its last legs, or getting towards the point where it's either going to short out and cause the whole unit to die, or short out and burn the circuit board, or just get really, really noisy, since it's already noisier than this motor. And this motor works. When I had the swinging cages on it, I did turn it on and make it spin just to make sure none of the gears were binding. And it works fine, and it's absolutely quiet. The plastic scraping is louder than the motor. So, anyhow, enough rambling. I shall be back in a few once I get all this taken care of. And I'll show you how to do the tracing, how we're going to extend the wires, and the whole nine. Hopefully we can get this thing done, make sure it works correctly, and pray it doesn't have this problem in the future. So anyway, be back in a few. Alright, another day, another step in this process for you. So I took the covers off because these 2 wires that were broke were from this the lights in here. When you take the 2 covers off, this has a flange that your heavy weight, you can see the groove, sits in. The weight slides out. It only slides out one way because of that flange. So that's now out of the way. Then I heated this up to slide this off because I can't get the wires to feed through with this angle. I'm probably going to have to pull this arm completely off to try and fish the wires through to this, and then fish the wires down. Now, the reason I couldn't fish the wires down is because of all the hot glue they put in here. That hot glue made it really annoying. As far as tracing the wires, it's actually pretty simple with the circuit board exposed. The ones that go to the LEDs, So you just tug the wire and see which one moves. And then the one that goes to the motor is the one that's attached to the one that says DY1. So we'll get this all fixed up. So I got my thinnest, and I thought I had thinner, but apparently I don't, stranded core LED wire. So I got blue and red, black and red, and green and black, so I can trace them, because this is green and black to begin with. But this is thicker. You might be able to tell the difference. So, but I got a few, 6 inches or so of each, just to help isolate them. So what we have to do is try and get the wire to feed through, 2 sets of wires to feed through. Let me make that clear, so we can get this thing fixed. And that's where we're at. I'm probably going to have to, like I said, remove this complete arm. The base is kind of an issue because it wants to flop around, but you can see how it pivots. The 3 screws and these 2 center screws, which are on the actual, it'd be a plastic bushing to where you can remove everything. So I'll probably take out the screws, take out the bushing. We still have a wire in here. That wire goes to these lights here, so we don't want to damage that if we can absolutely avoid it. The left arm only has the wires that go to this light and this light. The right arm, so right of the stairs, has the wires that does everything else. So if you have to take this apart, you're probably going to be working on the right side unless you lost the stuff on the left. But the stuff on the left doesn't go through the pivot or central axle, so you're probably not going to shear them. If you shear any, you probably sheared them right here, which would be the right arm. So anyhow, I'm going to get my stuff set up, and we're going to tear this all apart, and I'll show you how to do some solder the wires longer. Probably do one on camera because it's the same for all 3, how to solder and heat shrink, and then off camera to slow it down or shorten the video's length because it's getting pretty long. I'll do the others and then run the wires back down. Putting the sides back on. If I have some screws, I'll replace them so I don't have to deal with the ones that have the glue in the heads. And try and get these popped out if I can, because they're recessed due to the glue. They don't want to pull out like they're supposed to. And I'll get everything started back together. Before I do any of that, though, once I get it in, I'm going to make sure I have power where the motor goes, of course. But we'll come back to that in just a minute. We'll make sure everything works. I'll show you the majority of it on camera. The repeating stuff I won't, just to make it, again, shorter, because it's 3 sets of wires. If you know how to solder, once I do the first set, the other 2 is just redundant. And then putting the wires back in the center here. So I'll be back in just a moment. Let me get my stuff set up and I'll be right back. Alright, I got the stuff I need prepped. So let's take this thing apart. So I got heat shrink, I got my power supply on, I got the end split, so we're good. I made some extra room. So I think we're good to start this endeavor. I'll move that out of the way too, since we don't need it at the moment. First I'm going to do is I'm just going to remove the 2 screws from the white bushing insert and see if that'll give me enough play. It may not. The less you take apart, the less you're likely to lose or break. And it does. So just removing the white insert works good. Now, let's see about popping the base completely off. Oh, do they glue it? I think they glued it. Yeah, they glued it. Of course they did. So in order to remove the arm, we'd have to take the other side off. But with this out of where I can adjust it and move it around and a bigger hole, now that I have the ring out, the hole here is larger. I'm going to see if I can feed wire through to start the process. On this swinging arm, this notch right here is where the wires go. And then there's a viewing window right here that you can see the wires go through. So I know I'm in the right spot. I'm hoping I don't get caught on the wires that go to this though. For the wire set. And also I went and changed the batteries in my flashlight. I found out the reason it didn't work anymore is one of the batteries exploded. This thing takes 4. The other 3 batteries were still good. So I just replaced the one bad battery and it's good to go. That's why I was having so many problems with it. It's getting caught. It's a mighty small hole that these wires come through. Like small, slightly bigger than the wire. That might pose a problem. Let's see if I can do it this way. Might actually have to disassemble this whole thing. Let's try. This is a piece of fiber optic that I'm using. It's a little bit more flexible than the wire. See if I can get it to go into the hole. No, it just bypasses going down the entire shaft. Okay. See, can I feed it? So I'm going to try and feed it up. What I'm doing is I'm trying to create a fish tape where I can put something through, attach my wires to it, and pull it through the holes. Now it keeps getting caught right in here, so I'm gonna have to disassemble this some more. Definitely are not going to make this one easy to repair. Hopefully you never have to deal with your lights failing. Because there's hot glue right here again, like they did in here twice, right here and right here, which is stopping the stuff from going through. And to take this out, you have to disassemble the left side because all the screws are pointing left. And there's a screw here and here which you can't get to because of the blue plastic. Try one more time. Now that I can peel this top edge open, I'll use a pair of needle nose to pry it and see if I can be so lucky to get it to line up in the hole. And I did. I broke the fiber optic. Make sure you get that broken piece out so it doesn't get caught in the mechanism. But here we go. Part one of the process. Now we need to feed the wires through. And these wires are slightly larger, and then to do a fish tape you need to adhere, usually with tape, the other end. So there's a good chance this isn't going to work. But I'm being positive that it's not going to work. Now that I see the size of the hole, since I got this ring off, I'm going to see if I have thinner wire. There's no ifs, ands, or buts about this. This wire is going to have a hard time when I have to put 4 of these through there. It's not going to do it. I would love to use the solid core because it's as thin as the fiber optic, but the solid core can't be flexed a whole bunch before it'll snap. And this wire is going to pivot back and forth on the stuff. How thick is this wire? Is this thinner? That's why I have this, is because I use stuff like this when I take apart computers or other devices. I take the wire out because sometimes it's thinner and I just need short sections. So it's thinner than the stuff I have, but it's thicker than this wire. And there's only 3, as you can probably see in this image on your device. What are we going to use? Somebody asked a while back what gauge wire does Lemax generally use, and the answer is always going to be too thin. But it's normally between like 18 and 28 gauge, and that's the problem. It's so thin that it breaks. You know what I'm going to do? I'm going to go scavenge my part houses, and I'm going to see if I can get some wiring out of the parts houses. Matter of fact, I have one here at my feet. Let's see if I can cut some of this wire out. There we go. So I got gray, black, yellow, black, and gray, gray. So don't forget, I need to fix 2 sets of lights and a motor. Use a little electrical tape. I'm thinking glue might work better. Some super glue. Stick it on the end, let it cure, then cut the end off. But let me try the electrical tape first. I'm just going to try a small piece. And I'm going to hopefully get it to adhere. I know it'll stick to the wire, but I'm not sure how well it's going to stick to the fiber optic. So my only concern is getting the electrical tape to go through the actual hole, because that's the fattest part. If I get the electrical tape to come through and not pull the wires out, then I should be good. So what I've done is I've taped one set of wires lower, one set of wires higher. And see, it came out. So it didn't pass the pull test. Let's try it again. Go. See if I can get this tape off. Go. That's the one that didn't stick. Let's give it a whirl, see what happens. So when you're fishing, if you can, push with one and pull with the other, and then if you feel it gets stuck, move it back and forth. Let's see if we can get it to feed. What I'm doing with the screwdriver is I'm trying to, so there's a slit and the fish tape's going in like this. So I'm trying to bend it so it's more straight to the hole versus coming at an angle. So I'm using the screwdriver to push the fish tape over so it keeps it more in a line. But I don't think the tape's going to fit through the slit in the plastic that these are supposed to be in. That or it's stuck on the glue. Yeah, it just came off. So, okay, I am going to heat up this side and we're going to disassemble this whole thing. So I'm going to take off these two snowflakes and then pull off this entire side. Take the screws out so we can pull this piece out and then completely disassemble it. Run all new wires inside and then feed it through. Yeah. So this is going to be a fun one. So let's fire up the heater. I guess prepping the stuff didn't really make much of a difference. That one came off easy. This one's going to need a little bit more heat. That one was a lot harder. But it looks like these might have come out cleaner. So it took the glue out of the screw head. That one is. This one didn't. Let's try this one. That one's coming out. So 2 of the 4. The glue came out when it popped the snowflake off. So now we got the other 2. Little trick, you don't have to clean out the entire square. You can just clean out across as a line to make it into a the flathead. That's all I'm doing. It's just so I can grab the screw as a flathead to take it out. Okay, that one's loose. It's captive because of the glue ring around the top of the hole. And yeah, this one's really impacted in glue. Pushing down really hard, and because this is a plastic piece, I'm using my other hand to absorb the pressure so it doesn't break the arm. So if you have to do this for some reason, make sure you're aware you can't press down really hard on this piece. There we go. Is it a magnet? Interesting. That's a bearing. I have no idea what that's for. So there's the drive mechanism I was telling you about down here that moves the arm to make it an eccentric, so you can see it. Let's unscrew the white, which on this side isn't the bushing, it's the actual drive for the eccentric. So I'm going to unscrew that, which should allow me to lift and remove this. Now, of course, we still have a wire going through here. So what we do is we see which one is still hooked up, which is this guy here. And it's kind of like Humpty Dumpty. It's a lot of pieces. Gotta get them back together again, though. And then I'm moving it down in here so I can see which one's moving. So I can unplug it from the board. This one, which is the red, which is what I said before. Oh, it's not the red. That was my bad. Put the red one back in. That is this one, yellow. yellow. Jeez. No, it is the red. Why is it? Yeah, it was the red. It must have just been caught. Yellow is one of the other lights that aren't working. Now that it's out, you can see there's a screw there, 2 screws there, and that's it. It looks like the bottom just kind of cantilevers into place. But unfortunately, you can't get to these 2 screws. Let's get this glue out of here. The majority of these screws are all the same. Now, these 3 screws are shorter. So when you put them in, make sure you put in the short screws. And there's the electrical tape from the fish. Get that out. And here's the reason why it's sheared. I don't know if you can see that, but do you notice that the wire is actually crushed around the fitting? They didn't feed it around into this gap. It's crushed. I bet you that's why they're sheared so smoothly, is because it's literally acting like a shear. This fitting, this outcropping, losing the gears, this outcropping that lines up inside here has sheared the wires. This one's also cut. It's just not cut all the way through. With the magnifiers on, you can definitely see it. Oh my God. There's just some crappy assembly. Huh. Most likely, either this was built on a Monday or a Friday. If it's an old joke, if you've never heard of it. You never buy any products built on a Monday or a Friday, because Friday you're eager to get home, so you half-ass it, and Monday you're drunk from the weekend, so you half-ass it. You always buy products built on a Tuesday, Wednesday, or Thursday. So either this was built on a Friday, or, look at that, or this was just one that was assembled improperly. Look at that. I mean, that's just horrible. So that explains why everything's sheared. And when this is closed, the gap that this is inside, I don't know if you'll be able to see it in there, probably not. Is that where you can see the white, is very, very small. And if you miss it and you tighten these 2 screws down, you're just going to cut the wires off or damage them really badly. I really need to get some thinner wire. I need some longer pieces, because I'm going to have to cut this one up here and then extend this a few inches too. The issue is if I do it right where it bends, the solder and the heat shrink is going to be 1, too fat, and 2, not as flexible. So I'm going to have to cut the wire up here, just like these other ones. So I'm going to have to do the heat shrink and stuff in here, or I'm going to have to solder to the LED strips and then extend them down and then splice them. Or if I can just find a whole new piece, I can extend them all the way down and then just put on a new end. But I need to find some thinner wire, because now I need to run 8 wires in here, and there's not a lot of room. So I'm trying to fit it in that notch right here, and you have to fit 8 wires in there, which is why they used such a small amount or small wire. This bottom piece is locked in from this base, so I can't pull it out, but I can. It pivots inside, but this rectangle is got 2 indentations. I can see the pins, so it's pivoting on a set of pins, so you can actually just open it like that and go ahead and redo your wiring. There's a lot you're going to have to disassemble on this. This is not going to be an easy project, nor is it going to be a fast one, as you can tell. I'm on day 3 because I have a job that I work 10 to 12 hours a day at, half the day in the field, the other half on call. And then you can see how small these wires are, how intricate all these pieces are. So good luck. But it can be done. If it's already broken, unless you drop it, you can't make it any worse. So I'm going to go see if I have any thinner LED wire that I can use other than some pieces here and there. If that's all I have, then that's what I'll have to work with. I don't like using this thin stuff. I never have, because of stuff like this. If I can make this stuff fit, I will, but I don't think I'll be able to. because the wire has to be thin enough to flex to handle the fact that it's moving in here. The wire is physically pivoting, which is causing it to get stressed. So if I use too thick of wire, it won't pivot very well and it can bind, causing the arm not to swing properly. And then that puts extra pressure on the mechanism, which you already see this gear is broken, or the standoff is, which we're going to fix that too. So if I don't have this wire, I will just pause the video, put this in a box, and then order a roll of this really thin wire. So I'm going to pause it now, and either I'll be back in a few minutes, or it might be a few days while I wait for a spool to come in. And then we'll get this thing fixed. So, I apologize, I keep pausing this thing, but this is becoming a lot more intricate than anticipated, and I want to make sure that you at home can fix this yourself if necessary. So I'm trying to show you the important steps and cut out the useless things like soldering and heat shrinking, or heating up the snowflakes, which you saw me heat those up, so you get an idea how to take this apart and what to watch for in here, so you don't drop the board and snap all the wires. And then this is your main board, so in case you couldn't tell, there's your blob chip. That is the smoothing capacitor for the speaker, so that the speaker doesn't put noise into it. And this is your light distribution board. Everything on here is for the lighting. And then this is your main power board, your volume control and power on right there. Your power coming in, your power going up to the motor. So this board controls all the high-powered components, and this board controls all the low-powered components. So again, this is just a distribution board. And then it just distributes the power to the different lighting systems in here, so they can do their chasing and flashing. So yeah, that way I don't forget to tell you, since I should probably tell you now. That's if you're still watching the video at this length. So, all right, we'll be back in a moment on your time, and God knows how long on mine. So see you in a second. Well, it's been a week or so, week and a half. I finally got the wire, and I forgot to record, but I resoldered this up here. Basically, you can see the black. What I ended up doing was, with the weight out, I removed the wiring that was soldered to the light strip, which is right here. The small sheared pieces. There's two. And then I ran new 28 gauge red and black wire that I got off of Amazon down and through, and put the cover on so I could keep it in a line. So both covers are back on. But I think I said on the last time I was recording that I would show you how to do it. So I just left the wires loose down here so we can at least get this end hooked up. But I just used a little flux. I touched it to the two pads on the wire, and then hit it with the little fresh solder, and then took the original wires off, the two little green ones I just showed you. I soldered on just lengths of red and black, that's why they're so long, and then fed them through. I'm going to tell you, when you feed them through, it is kind of a pain because of the way this is designed, with its sharp angle on one side and a shallow angle on the other. The sharp angle is hard, which is right there. The wire is basically doing a 180-degree turn, and then once it goes in, it has to make another 90-degree turn down to this, and then another 90-degree turn, and then another 75, 80-degree turn. Take your time. It's a lot easier when that cover is removed. This one on this side, if you remember, we had it off. I'm sure you do, because the video is one solid piece for you, and it's a 10-day span for me. And then I did, because when I fed the wires through, this kept falling apart, I put those white plates back in so that this would stop coming apart, so I wouldn't tear this new wiring. This black that you see here is liquid electrical tape. Right there. Because I want to make sure that this really tight bend doesn't hit this when I put the covers back on. So It's just there to stop the metal from contacting the metal and creating a short, since this is a big lead weight or whatever material it is. It is magnetic, so it is a ferrous-based or metal. So, and that's when I realized I forgot to turn on that. So now we got all the wires run down here. So here's the 3 new wires, and then we have this old wire here, this old wire here, and there's another one that's still plugged in. And then we have the original wire right here, which is the center lights. And so what we need to do is get all these lights connected with these original connectors, and the other one's right here, and splice them in, and then test them, make sure they're going to the right areas. Now we know this special little plug goes right there, which is what powers this motor. One thing I did do is I did just hook power to this using some Arduino connectors to make sure that this motor does spin. And it does spin, which means that the repaired wire that was sheared for this has been properly repaired. So, and what I did with this one is I repaired it down here and then ran all new around. I don't want to hook it up 100% because the reason it's sheared is because of the broken gear that goes here. So I want to at least hook up the lighting, make sure that all the lighting works from the circuit board, then deal with this sheared gear. And once we get the sheared gear fixed, then we can put the whole thing back together. Because if not, it's going to swing this arm too far, and then all of these new red and black wires will get sheared again. So, because it doesn't have the ability to stop its over travel. So that's just an update of what has been done since the last time I saw it. And when I had it stored, I just put all the pieces inside here. You can see the feeder in here. I just put all the small pieces in an envelope and sealed it just so I wouldn't lose anything, because while waiting for the 10 days, I worked on other projects. Or else my bench would just be like this for a week and a half, and well, that would suck. Because I have a lot of these things to work on. Matter of fact, some of the videos you just recently may have seen was because I had this put in a box and just waiting for that spool to show up. So, one plug, two plug. We know the red one went over here, so we're going to leave that one unplugged because that's the motor. This yellow plug is the plug that goes right here. So I'm going to plug it back in, and then we're going to start splicing wires and doing some testing. There we go. And this one. This one goes under the rat's nest, but it goes right down here. Just need to lift these wires out of my way. There we go. And helps if I point the plug in the right direction. There we go. Push the board back down. Boards are just held on with plastic stakes. There's not a lot holding them in place. Let's turn the power test the lights. We're going to plug them in to make sure that they, so I can show you that they work, and then we'll splice them into the wiring. But for instance, this guy here with the red plug. That's the ground. Oh, it's the black. Me touching the two together. Okay, so this one's the lights in the middle. There you go. And that's the light on the back. I don't know if you can see it glowing down there. Look right there. See? So that's the back light. Because the wires are just hanging out, I don't know which one goes to which. So the back light's over there. Let's see what this one is. That's the front one. So the front and back will go over there. And then this one is probably the motor. That's why I didn't strip it. Because after I put all this together, it's been a couple of days. That's the motor. So, and we'll move this one over here so we don't get it mixed up. So, now I bought 28 gauge wire, like I mentioned. The wire, this is the motor down here. The wiring on this is actually like 30 gauge. I couldn't find any 30 gauge. Nobody had it in stock, so I own 28, so it's slightly fatter. It's not going to affect it any. If you ever have to rewire your piece, I recommend going to a slightly bigger gauge anyway, just for it's more resistant to breaking. You get better power transfer, but honestly, it's such a low voltage item that it's not going to make much of a difference. So, this is one of the ones that went up the side and has the glue in it. I'm going to, because it's going to be hooked to one of these shorter wires, I'm going to trim it farther down, right there, and get rid of all the excess. That's also, so when we put this back together, none of this excess bundle of wire hits the moving parts. Very important. There's a lot of wire in here and a lot of stuff that moves. Hook it to this one. I'm going to do the same thing with this one. I'm going to cut this back a little bit more. Two reasons. One, wire, too long, hit stuff, bad. But the other reason is me clamping onto it, some of the wire I trimmed off frayed and broke, so it's not a full bundle of wire. So I want to get some fresh wire that has all the strands. Sorry that some of this is kind of boring and monotonous, but this is what I do when I fix most of these. That's why a lot of it, the boring, monotonous, slow stuff I do off camera, because you'll lose interest. But it's all part of the process. So I'm doing this, I'm twisting the wires together so I can solder them. But it probably helps if I put this heat shrink on that I just totally forgot about. So I turned my soldering iron on, so it's getting up to temp. So on the original coloring, green is hot and black is not. So on the new wire, red is hot and black is not. So we just connect the black to black and the green to red. If you were wiring a house, that would be really bad. Now, if you're afraid of twisting and breaking the strands, always leave a little extra wire. Don't cut it so close to a board or to a connector that you don't have extra to strip. Because when you do like this twisting, you have a good chance of breaking the wire strands. That's one of the reasons I cut the red and black back a little further. And now we're just going to solder these. I know if a lot of heavy electronic soldering people normally don't twist the wires and then fold them over and slide heat shrink on them. You normally solder them in a straight line. Well, with these really thin wires, it's really hard to do, and you end up breaking them more than you end up fixing them. So when you solder and then take the twist and fold it one way and then slide the heat shrink over, it works just fine. I know it's not the correct quote-unquote way, but when you're working with really thin wire, sometimes you have to make changes. Where'd my lighter go? Now we just need to heat the heat shrink. I usually use a little lighter so I don't have to fire up the heat gun for 2 seconds. Apparently, I misplaced my lighter. Oh, it's right there. Guess I should pay more attention. I started rearranging because the laboratory is getting ready to move finally. It's almost the beginning of October, and finally getting the stuff. I actually started moving chunks of it yesterday when I had some downtime. Instead of working on this, which I know needs to get done, I needed to move some of the stuff so I have more room in here because everything's getting put in boxes. So soon I'll have a bigger area with none of this clutter, since I get comments you need to clean your bench. I'm fully aware. Trust me, I'm fully aware. Figure it'll take, with the other stuff I have to do, besides repairs, the other stuff I do in my daily life, it'll probably take me a good month to move everything over. I'm not going to stop filming. What we decided on is we're going to move all the non-important stuff over, or the parts where I might have to stop the video and walk to the other end of the house to get the parts. And then we're going to spend a weekend, and then we're going to move the bench, which this bench, I've never seen the whole thing other than what you see on the screen, which is mostly just this green mat. This is an ex-military electrical bench. It weighs about 400 or 500 pounds. It's steel with an 1.5 inch thick wood top on both the top and second layer. This is the second layer. There's another layer in front of me that the lights are attached to. And this thing is full. It's got big steel drawers. All the steel, you hear me move the steel drawers all the time when I'm doing this. It's got 7 steel drawers. I removed the small one that's in front of the bench right here. That's where I put all my belts. So yeah, it's going to be a fun little time. So, I'm actually kind of excited so I can have easier access to everything. I don't have to leave this little room to go grab parts. I'll have it in the same room, hopefully within just a few feet of where I'm working. Where did I come from? Oh, it popped out. That's the motor. Where'd the other, oh, that's the LED. That's the one I want. Started prepping the wrong one. But, yeah. And then once the new laboratory is set up and it's not shared with a refrigerator, I don't know if you can hear it humming in the background, we're going to do a live stream. And you can see the new laboratory, and we're going to build something on camera as well, take questions, messages. We're hoping to do it between Thanksgiving and Christmas, in that 1 month gap between the two holidays. Even though I'll be moving everything now and starting the process, the other room that it's going into still has to be emptied out, and it's going into this room. So it's going to be a process, and nothing's light. So yeah, we're going to just try and do a live stream, answer questions, comments, so on and so forth. At least a live stream related to this kind of stuff, because we have done live streams of video game stuff before YouTube changed their policy on video gaming streaming. Because the other guy that's a part of the RandomJChannel, that is also the editor, who takes all these videos and edits out the background noise like that refrigerator that's running. He used to do a lot of the video game streaming, which wasn't always on YouTube, but there are a few in our library of stuff. All right. If you don't have electrical tape, if you don't have heat shrink, you can use electrical tape or liquid electrical tape, but you have to let that stuff cure, which takes time, usually a minimum of 10 minutes. You can use regular tape. I don't recommend it, but it does work. I worked on a car where they used Band-Aids for insulation, so it works in a pinch. I've done it in a pinch. As a matter of fact, I was driving from Arizona to California for a car show, and the guy driving the truck, who didn't listen, jackknifed the truck, shearing the cabling to the trailer, and we got pulled over by CHP for not having any lights on the truck or the trailer. The dashboard still lit up and the daytime running lights were on, and that's how we were seeing, but we didn't realize the rest of the lights went out. And we were informed that we had no lights, so they let us go another mile up the road to an off-ramp to try and work on it. And believe it or not, there was nothing in the truck that we could use to splice the wires together. No medical kit, no tape, no nothing, which to me is annoying because I don't travel like that. But he had a brand new pack of Bubblicious. Told him to shove some in his mouth and start chewing, and that's what we use for insulation. We use Bubblicious bubblegum for insulation on, it's a good flavor too, with the watermelon, on fixing the trailer so we get it to the next town where I could rewire, on my vacation, rewire the trailer in a parking lot of an AutoZone at 6 o'clock in the morning when I opened, because I needed to get connectors and tools. Because again, he decided not to bring anything, and I figured it was his truck, he'd bring all the tools, and he didn't. So you can use all sorts of things as insulation. Doesn't mean it's correct, but in a pinch, you'd be surprised what you can use. And Bubblicious bubblegum makes a great insulator. Not only did it keep the wires from touching, kept the moisture out, dirt, grime. You do have to cut it off when you're done, though. You can't like unwrap the Bubblicious and reuse the wires. But I had to do a lot of rewiring all the way to the tail lights on the trailer because it burned the insulation almost all the way down the sides of the trailer. So I recommend trying to use what's actually designed to be used for, especially when it comes to power. But always think outside the box when you're in a situation where you don't have access or the materials to do what you need to do. I think I surprised him when I told him to start chewing because he just had this dumbfounded look on his face. I was chewing some too. It was his truck and he screwed up, so he had to do the majority of it. But yeah, little things that happen in life that stick with you. A lot of people know that when I go somewhere, I will take a toolkit big enough to pretty much rewire an entire car or rebuild an engine on the side of the road. I don't like to be caught with unexpected issues, since I swear to God, Murphy camps out in my back bedroom. Now, for those who don't know, Murphy would be Murphy's Law. Anything that can happen will happen. Or potentially happen. Alright, I think we got all the wires. Should be good. Make sure all the plugs are in. So we got 1 red, 2 red. The factory red and black right here is from the power. The red and gray is for this motor. This red and gray is for the speaker. This red and black is for the... Oh, sorry. This red and gray is for the optical sensor. This red and gray is for the motor. Red and black for the motor. Probably gonna have to glue this stuff back down. I think these wires were actually under the board based on their bend. That makes more sense. That holds them in place so they don't get caught in the moving parts. Yeah, there's hot glue here. This bundle. Either I'm going to try and hot glue it in here. If not, we'll pull it up the sides a little and glue it back up in here. Because we got to make sure that the black bar mechanism that slides here doesn't get caught on these two sets of wires right here. Because one goes on one side of the bar, one goes on the other, and that bar moves eccentrically inside the arm. Alright, so the wires are all hooked up. So technically, if I plug it in, you'll hear this motor spin. Just for a visual aid, and if you watch my videos, I do this a lot. You'll see the blue dot spin. This motor should be humming because it's spinning, but there's nothing hooked up to it since the little gears are over here. And then the big gear is in the box over off there. And then all the lights should light up. And the sound, if I turn the volume all the way up. So we should be good. Let's get that out. Let's plug in the Lemax plug. And fish it out. When I started moving stuff, I just threw everything in the corner of the bench, burying everything. Oh, this thing is so heavy with that weight back in. The other reason I have the weight this way is the weight, if you remember, only goes in one way. So I flip it over, the weight comes out, and then it'll tear up that new wiring I just did. There we go. It's plugged in. So, spinning. That one's spinning. Again, there's nothing on it. We got lights, the bottom lights are on. You might be able to see the reflection, hopefully. The lights are flashing back and forth. The two snowflakes are on. We got the noise. But now it won't reset. And it won't reset because the optical sensor isn't engaged. So, here's one of the gears, which I don't think is good enough to reach down far. So let's use something non-conductive should do. There we go. It also should be dark so it doesn't reflect. So the black strip. But anyhow, there you go. So electrical repaired. Let's unplug it from the wall socket. Now we need to fix this gear. And I told you I've repaired them before on the ghoulish gourd. It is possible to repair the OEM setup. It does require some modification, so this is what I'm talking about, the box. I just use the actual foam to hold this. So here's the gear. That's one of them. Another. And the part I need is on the bottom. And that piece there. And we'll move the foam back out of the way. So this is what broke. And this is what holds the gear. This is the gear for the top. Put that one away. So it goes in the center of said gear, like so. But it doesn't, it's sheared. So how you fix this, there's a couple of ways. And you do need to reinforce this. You can't just go, oh, I'll just glue this back into place. The torque this produces from its swinging and the abrupt stopping that this optical sensor creates will take that glue within 1 or 2 motions and snap it right off. Also, you'll probably never get enough of the grease out of the pores of the plastic. You can see how shiny that is. That's all the grease. It's all over my fingers. To provide a great bond, the grease will stop the glue from actually adhering. So, what's nice is, if you can see in the center here, there's an indentation. The indentation is when this was cast and they used a drill or whatever to bore the hole, it went into this base. So you're going to have to reinforce this. There's a few ways to do it, like I was mentioning. One, drill a hole all the way through right here and use another flat style screw. Come in from the bottom, glue after you clean this, and screw that together to make a sandwich, a bond. That's number one. Number two is on computers. If you've ever taken a computer apart or seen some of the other videos I've done where I've used them, a computer standoff. They're nylon, they're steel, meaning they're metal or aluminum. But what they do is they raise a circuit board off of the side of the computer casing so it doesn't short out and touch when it is doing stuff. And that is a much stronger option, but it requires a lot of modification because most of them aren't this small. They're usually a little fatter, and a lot of them aren't round. They're octagonal or hexagonal. So they have points, and if the points don't fit in here or they fit too tightly, you'll grind the center of the gear out and then the gear wobbles again. And then eventually you'll cause vibration and break the base instead of the standoff itself. So what we're going to do is I'm going to try it just screwing this back together way first. So I'm going to clean this out as best as possible with rubbing alcohol and swabs or towels. Reason I want to try and get as much of that grease to break down as possible because I am still going to use glue. I'm going to use glue and a screw. So, cotton swab, alcohol, the non-drinking kind. also need to clean off the sheared spot and the edges around it, because when we glue it, we're not just going to glue a flat, we're going to glue a gusset, meaning that we're going to put a little bead around the outside edge that acts as a gusset to the plastic to help reinforce it. The screw is going to do all the work, but you want something else to take care of it. Also, this screw is a deeper screw, so it goes about 3/4 of the way down. So the screw that we need to put in needs to go up enough just to touch the bottom of the screw. So if a screw like this, let's say, is too long, we're going to have to trim the screw. You'll have to use a set of wire cutters or a saw, or if you have a tool like this where most people don't know, these cut screws. That's what those holes are in the handles. So that's why I carry 2 pair, because they cut different size screws. That's all, again, all those holes. So in my work bag, I carry 3 because each of them has different screws. So it's a lot cleaner. I don't have the gloss from the grease, just where I'm scrubbing now. The discoloration from dirt and grime has come out. The tip of this is now gray. Let's get that to air dry. We also need to find a screw. So that's going to be one of the next processes. We're going to need to find a screw similar to the one that's there. A flat top screw, so it provides more grip. And here's a short one. It might be too short. Let's find out. Also, the bottom of this isn't threaded, so I need to get thread started. So I'm going to need a slightly more aggressive screw. And that's a longer version of what I'm looking for, but I guess we'll use one of these pointy guys to start cutting some threads. So just put it in and take it out, push it in, take it out, so it starts cutting a thread set into it. And the reason I'm thinking it might be too small is the thickness of the base has to be taken into account. And the thickness of the base takes up 50% of those threads. Also, I think this screw is too fat. Here's another flat screw. Much fatter as far as the flatness goes, so we'll get more pressure. And it has a more aggressive thread. Is it the right size? That'll work too. Oh, and there's a third option, which I totally just remembered now. The third option is you glue this in place. I know I said not to. You glue it in place, you drill a hole here, and use a nut and a screw, which is another option. Actually, it might be the best one for this because of the torque. So we glue this where it goes, but first thing we're going to do is drill out this hole. And then you use a small machine screw, hopefully with a flat head if you can get it. If not, you'll have to use a washer to dissipate the pressure. And then it comes through and you put a nut on the top. But to do that, you need to make sure you have clearance. And that's where you need this piece. And we put this in here, just so it sits. And then we set this on top, like so. And then we look at how much clearance we have on top of that gear. And our clearance is very, very little, which is probably why they use this flat screw. So our other option is, instead of coming in from the bottom and putting the nut on the top, you come in from the top and put the nut on the bottom. And then we have a clearance issue again. This only sits the height of those rubber feet off the ground. So as long as whatever you do or choose to do clears either this or the feet so the thing doesn't wobble, you're good to go. A little hand drill. And most Lemax, when I have to do this, use one of 3 bits. So I always have one of the 3 in its in my drill. This one is one size bigger than the original hole, and I'm going to go one size bigger so I can run a screw through the whole thing. You can use a power drill if you want. Just be careful. You can use a Dremel. Hand drill on plastic hobby stuff is fine. Gives you more control. Now I'm just using a drill to clean up the hole by spinning it and slowly raising it up and down to remove any of the internal burr. And you can basically get the idea what I'm doing, where now if we glue this and use a screw to center it, we will have our standoff slash shim. That's the shim or the axle that rides on. And the ghoulish gourd is the most recent one. I think I've mentioned it a couple of times that I've done this too. It had sheared these off, and I actually showed you how to fix them. There's more room on the ghoulish gourd. The tolerances were much, much greater, but alright, so I'm going to try and get this in. What I want to do is make sure I cut the threads to this pattern, because this thread pattern is slightly different. And then I'm going to glue it in from the bottom, or screw it in from the bottom, and then also glue at the same time. And I'm going to let it sit. I actually have a better idea. Why fight with it? Put that over there out of my way. I'm going to use this to cut the threads because there's a pointy one, not a flat tip. The plastic is slick, so keep sliding. What do I have for pliers? Probably overkill, but it'll hold them for me. More leverage. There we go. So now we have good threads. So if this doesn't work, and it may not, I'll do the screw all the way through. If that doesn't work, then we'll change it to a whole new boss or insert or whatever you want to call it. I don't know what its correct name is. I just know what I call it from doing it all the time. So it's this done here. Where is the big? It didn't crack square, so you can match up how it was positioned in here. At least this one didn't. Yours, if it's broke, may be slightly different. There we go. And hold it. Use the paintbrush. You can do this with the dropper, but I like using the brushed one. Apparently my glue is getting a little thick. And I'm going to put a bead around the seam. And that's what I'm talking about, kind of making a gusset, it'll fill in the seam to the crack, and it'll add a little extra strength. You don't want it too thick and it'll interfere with the gear itself. So make sure you don't build it up too much. We just need a thin layer. I can't emphasize that enough because I've seen attempts where it's too thick. Now I'm going to use another cotton swab, and I'm going to wipe the excess glue off of the shaft because that's what that spins on. So if the glue hardens, that becomes extra friction. Go. Now we're going to let it sit. I'll let it sit for a few minutes to cure, harden up, and then we're going to test it. So make sure that this will still drop all the way down. And it won't because I got glue up high. That's what I was talking about. Let's see, it's already cured a little. This one should be fine. You can use sandpaper for this too, but I have a ridge. I'm just going to see if the X-Acto knife will get rid of my ridge. Still too tight. Oh yeah, I can definitely see the hard glue. Dropper might be a better idea. You might be able to get it closer without getting any on the axle shaft here. Oh, there's my handheld one. I couldn't find the handle. It goes on, it just doesn't go all the way down, so my ridge at the bottom is too high, like I was mentioning. glue is almost cured. So before it cures 100%, I'm going to clean off this top ridge. Now when you put it back together, don't forget to add lubrication. That's a lot nicer. Alright. See a spot I missed. It's just hanging off. You can also use a resin glue for this, but you have to let it cure for 24 hours. It says it's good in less than that, like 10 or 12, but I'm going to tell you from experience, let it cure for the entire day. Because, oh my gosh, it changes the bond. Let's turn this out so it's in alignment. Turn it about here. And see if it'll go all the way now. And let's plug it in and see if that turns. It's still a little snugger than I like. So either it's going to work or it's not. Thumbs up. It's working. Alright. So we're going to put a screw in the top. I'm going to change the screw. I'm going to leave the screw that was in the top in the bottom. And if I remember these. If I remember right, I was missing one too. Except for me, it's been a week and a half. Those are not the right size. Forgot to screw the gear down. I'm sure this screw is going to be too long, so I'm going to have to cut the screw by 1, 2, 3 threads. Cool. All right. I just noticed, I don't know if anybody's taken one of these apart before, but this side is recessed to this side, so basically this side sits higher and this side sits lower. It's kind of interesting. The plate's not as it's tapered, or it's I don't know how you'd say, stepped. I want to make sure those are in, but they're not so tight that the plate doesn't have some slack. Oh, I don't know if this screw will fit for the one that was missing. Let's find out. Nope, too big. It's the same screw I just used for the motor gear part. Let's see, will that one work? It's going to be too long, way too long, so let's trim this one too. Come out now. There you go. The screw is a soft metal screw and it's smeared and it's caught between the teeth. There we go. Grades, or if you ever pay attention to grade 8 bolt or grade 5, screws are graded too, and if they're too soft, usually for hobbies they are, the metal doesn't just snap, it smears, and that's what it did, and that screw is still too fat for that hole. What's this one? I got hobby screws everywhere. Maybe that's why I was missing one. Maybe they just ran out. It's too fat as well. Too fat. Too fat. Ooh. Wait. Is that the right size? It is. Just need to trim it. Doesn't fit in the same hole as the motor. No, it's not. Well, it only had 3 when I got it, so I might just leave with 3, because that is a smaller than standard hobby screw. Maybe it only had 3 because it was binding. I don't know. It's kind of weird. What's this one? Yeah, these are all the same size shanks I have over here. Just one size too big. Got lots of them though. Oh, wait, we got another one over here in the corner. Dust. That's the right size. So the last one I have. So let's trim this one down to 3 or 4 threads. Look at the other ones. There we go. Watch, because I'm replacing a missing screw, it'll be non-functional because 4 screws is too much resistance. Although it's not really resistive, it just keeps the plate from bouncing up and down. That's all it does. So it can't lift out of its hole. Just make sure it still turns on and off. Make sure that it's not too resistive. Put a little lubrication in the track. Turn it on so it mixes it. And center. And there. So this is a resetting piece, which I think we went over before, but in case we didn't, make sure you don't turn it off from the power strip, especially if it's in a up position where it's swinging. That's going to be a lot of weight pressure on this plastic arm, on this metal pin here. So make sure it resets. Before we assemble the base, we need to get this piece done, because this, without it being hooked up, I can hyperextend it to a full 90-degree position. It puts the arm too high, which is why this probably got broke. At some point this got hyperextended, maybe being put away, it was tipped upside down and the weight swung. I don't know. Somebody could have tried to stop it or help it, or it just broke from age. God knows. Anything is possible with these. So I need to stand up for this piece, because I'm not, this thing sits high on my bench. Not that. That. And the only thing left in here are the snowflakes that go on the sides. So, and then the rest of the parts are right there. So, alright, let's do this. First, let's get some of that out of my way. Got some planetary gears. We got the drive gear. We got the full cover. if I remember right, this has to go through here, like so. So I definitely need to unplug it. And now we need to drop the planetaries in. One goes there. One goes there. Then the drive gear, which got dirt on it. So let's clean it off real quick. There we go. Gondola. Where'd the lady in pink go? Right there. Hold on, this one, she's the furthest forward. Yours may vary. Come on, get off the teeth. Come on, lady. There you go. And there we go. Like I said, on mine, the pink lady there, or at least mine, the one I'm working on, it's not mine. She is the furthest forward. So if you can get her to go on last, it usually pops in. It's not loose, it's just she's the furthest forward in the group. So now we can put this through, like so. Get this to line up. Sorry if my head's getting in the way, I have to be able to see. That's what I thought. Thought I put that gear in upside down. If I remember right, I did this the last time, and I can turn it without disassembling the whole thing. To me, it's counterintuitive. The gear should go in the other way, but I didn't build it. I just fix it. There we go. Like that. So then this should line up. And it does. So I'm going to put a little grease on the teeth. Not a lot. We don't want to burn out this motor. And a little on the hole for the shaft. These still have plenty, but I'm going to put a little bit right there. And of course we're going to lubricate the shafts on the planetaries. And then remove the hair I just introduced. There we go. Less is more. Less grease, longer longevity. Sounds, again, counterintuitive, but that's because the grease gets into the mechanism and burns out the motor. The last motor was greasy, and even though it was a sheared wire, the reason it wasn't working, when I tested it on the machine, it was putting out too much, or was pulling too much amperage. So it was a defective motor. Very, very common on these. The plug isn't lined up. I had to pull the plug out to fix the wiring, and apparently I didn't seat it all the way. the black plate was at an angle. When I put the first screw in, it didn't seat. So I'll put that one in first, just a little, just to keep that plug from shifting, and then we'll put the rest in. And that's 2, and then another taper screw right there. I grab a short screw. Ah, the planetary gear fell out. Son of a biscuit. That's why it would give me a hard time with the screw. Come on. That guy. Alright, I'll tip you back up. And should have, but it didn't line up with the boss hole. There we go. Bet you when I that screw's gone. Bet you when I rearranged the plug, it moved. Well, I dropped the screw, but it's the same screw as half the other one, so I'll find the screw in a minute. I don't see it immediately at my feet. Now, before I plug it all in, and let's test this now. I'm going to test it using the machine to ensure that it spins freely and it's not binding. So I'd hate to put this all back together to have it not work. I've had that happen. It's not fun. So I'm going to use that, and that one will go there. It's not going to spin fast because I'm not going to run at full power. There we go. So that's full power. And I don't know, the board may not send a full 4.5 volts up to this thing. It may only send like 3, which is what I started it at. Click. And you can glue the motor wires down. There's really no point. They're not going to get interfered by anything on top of that black shroud. Trying to not get the sticker underneath the edge of the screw. You can smear a little glue on here to hold it in place. Can also use spray adhesive. Don't spray it on here. Spray it on a mat. Put a thick glob of it. Piece of parchment paper or something. And then use a cotton swab and dab the edges so you can fold this down. And then you can re-adhere it. I'll probably do that when I'm done. But just spray it. Use wherever the hell I put it right here. Cotton swab, and then just dip and then press, just using spray adhesive. You don't want a lot, but you just want enough to hold the sticker corners down. Alright, so now let's get this thing back down. Now let's do an actual test using the entire unit, and then the rest of it can be reassembled afterwards. So just to get that out of my way. This part might take you a few attempts, so just be patient. I got the thing aligned with the hole, but I noticed my wires will get pinched by the screws. There we go. So it should be good. I just need it to pop in its recess. I'm using my thumb to hold the bar centered. And that should be recessed in. And there goes nothing. And then off. One more swing and then done. Cool. So I need to adjust the wires because I can hear the wires rubbing in the base. And then of course it all has to get glued back together. You know, the pieces, the whole bunch of stuff. I gotta find the screw I dropped so I can screw the bottom back on. Because again, a lot of these screws are the same. So since this video is many hours long now, I'm gonna pause it. I'm going to glue the wires up inside. I'm going to put them up inside the arm. I'm going to screw the bottom on, and I'm going to glue all the stuff back to the sides of this bad boy, and then we'll come back for one final check and see what it looks like in low light. So if you've been watching this long, sorry for how long it took. You can only imagine how long it's been for me off camera, so you get an idea what I do. Anyhow, I will return in just a moment with a, hopefully at that point, gotta put the sign back on it, sliding backwards from it spinning. Hopefully fully reassembled and functional piece. Be back in just a moment. Okay, we're back. It's all back together again. I used hot glue on the snowflakes. I only glued the centers, not where the screw holes are like they did originally. I use hot glue on the sign so it's still accessible. I have to clean off the residue. You can see it right there. The pads are in. I used the Gorilla spray adhesive on a cotton swab and stuck the sticker corners down. And when you put the screws on the bottom, tip the machine this way or this way. Do not go forward or backwards and cause this thing to swing, because then you have the problem of breaking that gear again. So, that was it. It's just those, the bottom, the sign, and the corners. Yeah, so here we go. I know it's swinging outside of the camera's purview. But I have an idea so you can see it better. I don't like the way it just stopped, but we'll turn it sideways. There, well, it's always in the screen now. And then off. I don't like how it kicks back, but that's how it was when I got it. And the one I worked on in the past, I didn't film because I didn't do anything important to it. I just extended this. Same way. It always kicks back, meaning that the piece is farther back than the unit. So, this super long video, if you watch the whole thing, I'm sorry, but sometimes these things take a long time, and they're not the easiest. I'm going to go ahead and clean up this glue now that it's dry, scrape off the extra blue glue so it's not so ugly looking. Blue glue. The hot glue, that's blue tinged from the plastic. So, this is a pain to work on, only for the fact of how it's designed. If your gear breaks free, use a screw through the bottom, a pin, a replacement, fix that. If you look at the glueless gourd video, you'll see that one as well. 2, if you shear all the wires, 28 gauge wire from Amazon is what I used. I will put a link in the description. It's a spool. I think it's like 25 feet or something like that. 24 feet, sorry. And you can solder and connect. Use solder and heat shrink, which is the proper way. But if you don't have that, you can use electrical tape. It just takes up more room. You can twist it together and tape it, is what I'm saying. You don't have to use solder, but it's recommended. If you're light shear, we know it's right here at the pivot or the axle, you're going to have to disassemble everything. There's no shortcuts because of the width of the hole that they feed everything through is slightly bigger than the set of wires that go through it. You're not going to be able to get it. So, yeah. If your motor goes out, and it's just the motor, it's not sheared, just the motor, the one in the gondola, you can work on it without disassembling it. You can technically let it swing and then turn off the power. Not here, but unplug it from there, and it'll stay. But immediately after you do that, reposition it so there's not so much stress on that plastic gear. Do not run this on a power strip that has a master kill. This has to be turned off individually. So if you do run on a power strip, turn this off first, wait till it comes to its resting point, and then turn off your power strip. If this thing sits up for any duration of time, it's going to cause stress on that gear and shear that pin. Also, when it restarts, if it doesn't know where it's at in its arc, it might try to go farther in the wrong direction, and then you break stuff again. So, this is using an optical sensor and not micro switches. So the optical sensor is very sensitive to light. That's probably why they have it encased in the bottom down here. If something interferes with that light, you're going to have problems. Now, it is a black piece of plastic, which absorbs the light, breaks the light beam, so therefore you shouldn't have any issues. But if too much grease gets on that black piece of plastic and becomes reflective, you're going to have a problem. So the flag or the outcropping or the bar that goes between the two sensors, make sure there's no grease on it. The whole thing was greasy, but that edge wasn't. And there's a reason. You don't want to reflect the infrared light. It causes issues. And Lemax is not the only piece. or company that uses the optical sensor. Mr. Christmas does too. Most printers use them on their spool. There's a wheel that has a disc with holes in it, or a disc with black lines. Hell, if you have a Cricut, they have them too on the inside. The optical sensor tells the circuitry where in the rotation of the shaft it is at. So on a printer, Cricut machine, etc., it's a 360-degree wheel. The bar spins in a circle, and it tells it at what degree of that 360-degree pie the shaft is in, for spooling your paper or moving your Cricut's head back and forth, or Cameo or Sicer. You know, there's a whole bunch of vinyl cutters out there as an example. On this, it tells the unit when that flag goes past, okay, reverse directions, or we're good. It comes back again, same thing. And then when it clears it twice, it knows to stop it when it breaks the beam on the third time. And that's when it stops at the bottom. So, because that flag is about the same width as this stripe here, that's why you have play where it stops, back or forward. I had this running to make sure none of the crap fell off of it when I glued it on, because the one sign did fall off, because apparently the hot glue wasn't hot enough yet. You need to make sure that it stops in this bottom position, but it may stop forward or back of front, anywhere within the width of that black plastic blocker. If I were to push this, even though it's off, past its point, it's going to turn back on and reset itself. But when you push it, you're pushing all those gears backwards. And in some cases, it's fine. Technically, the way this is set up, it should be okay. But we already have a weakened shaft because it broke. I know it's reinforced with glue and a screw. We don't want to put any extra undue strain if we can avoid it. So, this is a more than normal fragile piece. It's fragile because you got the swinging gondola where you could break the characters off. You could rip the LED strips because they're all exposed. You can see, you hear the bump. They're not covered or protected like on the Ghost Around or Roundup or the flight schools, whether it be Zombie or Junior. They all have a plastic. These are recessed behind plastics. You can't hit these LEDs. Because if you knock one of these off, the strip's not going to work. One side. The reason they flash back and forth is if you see right here, you see the 3 copper pads. That's where you can cut the strip and extend it or shorten it. The reason it works is where it rotates the lights back and forth is it reverses polarity. So it sends DC this way, then it sends DC this way. So half the lights turn on when the voltage is going this way, and half the lights turn on when the voltage is going that way. That's just a basic, not a scientific way of telling you how it works. But that's why there's 3 copper pads right there. And that's how it does the rotating lights, as it goes left, right, or forward, backwards. It's alternating the current is what it's doing. So if you break one of these lights off, you're going to lose that side. You break 2 of the lights off together, you just destroyed both sides. So this is a little bit, like I said, more fragile of a unit because of how it's built. You can knock the wings off and break them, and there's lights inside. You can rip the LEDs off of the arms or even the center shaft because there's no protection. You also have the ability of making this swing past its stop point, and it'll turn back on if it's plugged in and it has power. Or you'll break the gear at the bottom. So, I mean, this thing has a lot of fragile components and setup. It looks cool. That's why they say it's not a child's toy, because you're just supposed to turn this on and let it do its thing. You're not supposed to go up and interfere with it in any fashion other than to turn it off, turn it on, adjust the volume. So, this is a cool piece. I like the way it lights up. The swinging ones are always interesting because there's so many ways to make them swing, and each time I come across one, they seem to do it a different way. But this one, be careful. It is going to be a problem child if you break it, and you're going to spend hours rebuilding it, especially if you shear all the wires that go through the axle right here below this counterweight. Also, the counterweight, one side is tapered, so you can remove it when you remove the sign, so you can fix the lights if they get sheared. But be careful that if you tip it, that you're not on the edge of your table and you're wearing shoes, hopefully, that half-a-pound chunk of steel doesn't smash a toe or your finger if you have it down and you tip it and it lands on your finger. So just be aware that this one's a little bit more fragile than standard. for Lemax, and you have the potential of injuring yourself with this counterweight if the signs pop off, or one of the sides, and you're working on it. And if you do have to fix it, take your time, be careful. Wires are thin, they shear easy. Mark your connectors if you need to. Just know that the one smaller board was over here. The one that was higher up off to the side is the LED distribution board. Everything that plugs into it are your lights. And then the bigger board is your main power board. It's got the blob chip. It has the incoming circuitry, the power, the smoothing capacitors for the two motors, all of that. And that's why those plugs are bigger, is because those are for the higher powered components on this board. Except for the one plug that then jumps to the other board to give it juice, of course. So, well, hopefully this helps if you have this piece or need to work on this piece or want to see what the insides of this piece look like to determine if you want to buy it and risk it, lasting. Because they use too much grease in all their motors, when you put this one away, try and put this one away where it's standing up like this. If you put it in the box and lay it on its side, you risk having the grease from the gearbox run down into the motor here. And then on this one, the same principle. Now, if you lay it to where the stairs are facing down, this gearbox will have was where you'll fill up the motor. If you face it where the stairs are pointing up, the grease will run towards the back. But that's where your power is. You don't want to plug this thing in, have the grease short out your power input port, and then smoke. This motor, it doesn't really matter. If it's laying on its side, you have a good chance on how it's positioned, as you're going to get grease in it either way. I didn't put as much grease in here as I did when it first came, but it still could technically be enough to ruin the motor if it's positioned in a lying down position over the course of a warm or hot summer, or in storage where the temperature gets higher than normal. So, just some tips to help prolong the life of your unit. If you have to open the sides, remember the side to the right of the stairs has all the LED wiring for everything except for this snowflake. The left side has this snowflake. So that's it. So if you have to take it apart and you want to check your wiring, it's this side. If you have to disassemble it to refeed to the axle, you have to take this side off too. Pop the snowflakes off, use heat. You only have to pop the two off on the top, not the bottom one. There's no screws behind it. And then there's an indentation right in here for a screwdriver to pop it out, as you saw. Careful, because of course you still have wires going to these two snowflake wings. What else is on this? The sticker, I did spray Gorilla adhesive on one of those cotton swabs. And I wiped some on all 3 points, let it sit for a minute, and then pushed them up. They're sealed. There's a slight wrinkle because, of course, that material's thicker than the factory sticker material that's on the back of a sticker, but you don't notice it unless you're really looking for it. But that way, at least the sticker's still intact and it's not peeled completely off. And I didn't have to rip a hole in it or tear the corner or so on and so forth. But yeah, I think that's all on this piece. So if you have the spinning snowflake, try not to damage it. Because it's not the easiest to work on. In worst case, hopefully it's just something like this quit spinning, and then you can replace the motor in the gondola, and it's not sheared up inside the axle. And then don't overextend the pivot. So if you do work on it, don't pivot this past 90. One, this mechanism down here can't take it. Two, that's when this becomes a shear. So just be careful. So, other than that, any questions, concerns, or comments, leave them below. Hopefully you could handle this one. I know this video, I believe, with all the different segments is over 2 hours, and I apologize. I've been working on it for close to, I don't know, 6. So it's a little bit of a treat. I'm going to clean it up a little. I'm going to clean off the glue, clean off the smear with some rubbing alcohol, put it back in its box, and let the owner know that it is ready. And we'll work on the next one. So, thanks for watching. Till the next video, have a good one.